Okay, formation of esters, let's have a look. So there's our ester bond, carbon double bond oxygen, bonded to an oxygen. See if you can work out the one that I'm drawing here. So I've got 3 carbons on the right hand side, so that makes it a propyl, and 2 carbons on the left hand side, so that's from the carboxylic acid. So that one, that's how we name them. So from the alcohol first, so that would have been from propan-1-ol. So that's the first part of the name. So that's propyl. And the second part of the name from the carboxylic acid or derivative. So there's 2 carbons there. So that's ethanoate. We're going to have a look at some different ways to make an ester. The first way is from a carboxylic acid and an alcohol, probably the way that you're most familiar with. So again, we're making propyl ethanoate on each occasion here. That's the alcohol that we'd need, so that would be propan-1-ol. The carboxylic acid we can see there in green has 2 carbons, so that's ethanoic acid. Here's the balanced equation. So ethanoic acid, propan-1-ol, and we'll just squeeze the structural formula in for our ester propyl ethanoate and water. Okay, second way to make an ester from an acid anhydride and an alcohol. No change with the alcohol. Acid anhydride, a little bit more unusual though. So where do we get the ethanoate group from in an acid anhydride? A little bit more detail on acid anhydrides. So we're fairly new to these. So this is the general formula for an acid anhydride. Symmetrical molecule, and they will always have that. So it's basically 2 carboxylic acid groups that have come together with a loss of water. So the one that you'll see most often is this one. So we'll be after the ethanoate group, so we just want 1 carbon attached to each of the carbonyl groups like this. So this is ethanoic anhydride. So the ethanoic showing that we've got, and it's symmetrical, so we've got it on both sides of the acid anhydride. So we know that we need ethanoic anhydride to produce the ethanoate group in our ester. So see if you can work out what the reactants are. So in addition to our propan-1-ol, the acid anhydride that we need. Here it comes. So there's those two carbons that we're after with the acyl group. So in addition to our ester, what we're also going to get, we can see the other side of the acid anhydride. We're left with that, which I'm sure you can see is going to give us a carboxylic acid, like that. So in this case, ethanoic acid. Third way of making an ester is with an acyl chloride. So fairly new to acyl chlorides. So let's have a look at the acyl chloride. Again, we've got the carbonyl group, and as you can imagine, there's a chlorine involved. Very reactive acyl chlorides, very corrosive. To provide us with the ethanoate, we just want 2 carbons in our acyl chloride, and this is ethanoyl chloride. It's the one that you'll see by far most often. So ethanoyl chloride. So for propyl ethanoate, the acyl chloride that we're after, in addition to our propan-1-ol, there it is again. So we're going to need ethanoyl chloride to make the ester. So there are 2 carbons and the carbonyl group that we're after. What's left behind? Not an awful lot. So we've got the hydrogen from the alcohol and the chlorine from the acyl chloride, and that just leaves us with HCl, hydrogen chloride.